Hi Algebra 2 students, we're looking at another Edpuzzle video. We are continuing to work in our notes. You should have just completed the notes that you see here where you are working backwards given the roots to find the function. So we're looking now in our notes. You'll see it's labeled example 6 and this will require your calculator. If you don't have a calculator, you need to contact your teacher and your teacher can send you a calculator form. You can take that form to the front office while we are on virtual and then they will bring you a calculator out. Until then, there is a TI-83 on your Chromebook that you can use. So as we're looking at this, we're going to use our calculator to determine some of the information that you see here. So first off though, we know since this is a polynomial in standard form, it's a degree of 4. And a degree of 4 is called a quartic. It has 1, 2, 3, 4, 5 terms. There's no fancy name for that number of terms. So if you'll grab your calculator here, we're going to graph this. So to graph, simply hit y equals. And I'm going to go ahead and clear what's in here, and I'm going to type this function in. So I'm going to have x to the 4th plus 7x cubed and then I have plus 6x squared minus 32x minus 32. And then up here at the top, I can hit graph. Now, I may not be able to see all of my calculators, so there's a couple of different ways that I can adjust this. As I look at my calculator, it looks like I need to see higher, and it also looks like I need to see lower. So I'm going to hit window right here. So if I need to see higher and lower, that's changing the y value. So my y value right now is negative 10. Let's make it negative 50. That will allow me to see lower. My y maximum right now is 10. Let's make it positive 50. That will allow us to see higher. All right, so that did it. It looks like I can see most of my important things. So a couple different questions I'm asked here. It says, what is the local maximum? And so I have one local maximum here, which means I need to go to second, calculate, and this is the same way that you found a vertex on a quadratic, and I'm going to go to maximum. I like to put my calculator cursor on that maximum, on top of that maximum. And so it says left bound. Move your cursor to where you're just a little to the left of that maximum and hit enter. Right bound. Move it till you're a little close to that, go to the right hand side of that maximum, hit enter again. And for guess, you just kind of go on top of it and hit enter one more time. So remember, maxes and minimums are y values, so our local max is 16.339. And that occurs at x equals negative 2.171. Always round to 3 decimal places there. Next it says to find any local minimum. Well, that's going to be your low points, and we actually have 2 of those that we need to find. We have 2 of those that we need to find. So I'm going to go to second calc, second trace, and do minimum. I like to scroll my calculator till it looks like I'm on top of a minimum and it's flashing. So now it says left bound. Move your cursor till you know it's on the left hand side of that minimum and hit enter. Now move your cursor until it's on the right hand side of that minimum and hit enter. And guess kind of over to it and hit enter one more time. And so we see here we have a local minimum of 0 at x equals negative 4, and actually that's an x-intercept, negative 4, because the y value is 0. I have another minimum, so I'm going to go through that process again. Second, trace, minimum. take your cursor and kind of scroll over to that minimum. Go to the left-hand side of it and hit enter. Go to the right-hand side of it and hit enter. Kind of put your cursor on top of it and hit enter one more time. And so I see I have another minimum at negative 50.194. And that occurs at x equals 0.921. So we've already found one of the x-intercepts, and by the way, I know since this x-intercept is a bouncing, it's going to have an even multiplicity there. So that would be, it would end up being 2 here. And then I see that I have, and we'll talk more about why it's 2 in just a moment, I see that I have 2 other x-intercepts. So same way you did with the quadratic. Second, trace, 0. So find your cursor, and I like to kind of start by putting mine close to as possible on top of that x-intercept. And so the screen says left bound. Move your cursor until it's to the left of that x-intercept and hit enter. Right bound. Move your cursor until it's on the right of that x-intercept and hit enter. Guess. Hit enter one more time. So we see that we have negative 1, 0. Since that is crossing through at that x-intercept, I know that it's going to have odd multiplicity. I have another x-intercept here. It looks like it's 2. Second, trace, 0. I like to orient myself by putting my cursor as close to on top of that x-intercept as we can get. And now it says left bound, so I'm just going to move my cursor to the left-hand side of that x-intercept and hit enter. Now it says right bound. Move your cursor to the right and hit enter. And guess, you kind of get as close to it as you can, and yes, 2, 0. Since the graph crosses there, I know it's odd multiplicity. Now let's talk about how I know the specific multiplicity here. My total degree is 4. Total degree is 4. So that means when I add the multiplicities together, it's going to have to equal 4. Well, for this one to be even, it's either 2 or 4. Well, 4 is too much because that would be the only x-intercept so I would have. So I know this is 2. And then we would have to have 1 and 1 here. That adds to 4. Notice all those add to 4. All right, what would your domain be? Well, if you remember the definition of a polynomial, you can draw it without lifting your pencil. And the domain here is all real. Range, you always go down to up. So if I think about my pencil, does my graph exist here? No. The lowest y value we have is the y value of this local minimum, which we found. We found that to be negative 50.9194. 2, and if you look, it's continuing to go up and up and up to infinity. This time you're going to try answering a few of these questions. And so I've got a problem here. First off, if we want to classify it by degree, once again, it's a quartic. What would we call the number of terms? If you said trinomial, you got it. So go ahead and go to y equals, okay, that's here. Clear out what's in there and type your function in. I've already done that. So I'm going to go to graph. I see I can see low enough. I just need to see higher. So I'm going to remind you how to change that. Hit window, and to see higher, I need to increase my y maximum. So it's on 50. Let's try 70. Oh, not high enough. So window, let's just go ahead and do 100. Y max 100. That will allow me to see higher. I'm still not quite there. that would actually end up being sufficient for the purpose of what we need. But we'll go ahead, let's change it to 120. There we go. All right, so you're going to do some work and answer the Ed Puzzle questions. So the first thing I want you to do is I want you to find any minimums. So go ahead and do that on your calculator. Hopefully what you found is you did second trace and you did min. Here's your one and only minimum. It appears it's at 0, so let's go left bound and hit enter. Right bound and hit enter, and enter one more time. And notice this is scientific notation. That would mean that you're going to move your decimal point left, that's what the negative means there, 6 places. Well, think about that. You would have negative 0.000018. That's really saying 0. Same thing here. This would mean move your decimal point left 11 places on my calculator. Yours might actually have done 0, 0. So there's a minimum of 0 at x equals 0. Now that also tells you something else, but we'll come back to that. So let me give you a few moments. I want you to find the maximums, and I want you to notice there's 2 of them. Second trace, maximum. So I like to put my cursor close to the maximum, and then left bound, hit enter. Go to the right side, hit enter, and then enter one more time. So we've got a maximum of 48.422 at x equals negative 2.103. Okay, what's our other maximum? Second trace, max. I like to put my calculator to orient it on top of that maximum. Left bound, hit enter. Right bound, hit enter. And then enter one more time. The other maximum's 109.289 at x equals 2.853. Notice I rounded to 3 decimal places there. Next, let's find the x-intercepts, and as you can see, we've got 1, 2, 3 x-intercepts. Now, you should know what one of those is already. One of your x-intercepts there is 0, 0. And it is going to bounce, and so that means it's going to have even multiplicity. So I'm going to give you a few moments to answer the questions below about the other 2 x-intercepts. All right, to find those other x-intercepts, go to second trace, 0. Your calculator will only find one at a time, so orient your calculator, put your cursor on top of one of them, left bound, hit enter, go to the right hand side and hit enter, and guess you just kind of grow on top of it and hit enter one more time so we can see negative 3, 0. Second calc, 0, orient yourself by moving your cursor on top, or as close as you can be. My cursor won't get exactly on top of it. So I want to be on the left-hand side of my x-intercept, hit 0, or enter. On the right-hand side, hit enter one more time, and guess you just kind of toggle between the 2 of those, getting as close to it as you can, and you see it's 4, 0. Both of these have odd multiplicity, so it's going to cross at those. And actually, since this is a degree 4, I know the specific multiplicities. Your domain is going to be all real. See if you can find the range. The range you should have, if you take your pencil, ranges down to up. So the question is, would your graph exist here? It sure would. That's negative infinity. Up to whatever this maximum value is, which you have already found.